Hey everyone, welcome to Homeschool and welcome back to Mind Map series where we started our revisions with the help of drawing mind maps, isn't it? Say already few chapters are over and this is our next chapter, that is periodic classification of elements. So today's mind map topic is periodic classification of elements. See, this is a much simple chapter but yet very important chapter in chemistry, that is periodic classification of elements. Okay, so this is our center topic, right? So what are the things we studied in a chapter is, say first and foremost, we studied certain periodic tables in the history, right? Say the periodic table that we are using present is modern periodic table. Whatever the periodic table you have in your textbooks and the various concepts based on the periodic table is our modern periodic table. So before our modern periodic table was introduced, there were many periodic tables. So among the many periodic tables, we are studying three periodic tables. Under that, the first periodic table was, Dobereiner's law of triads. So the first and foremost, we studied Dobereiner's triads. Dobereiner's law of triads, isn't it? So you must understand what is Dobereiner's triads. Okay, Dobereiner's triads are nothing but group of three elements. He arranged the elements in a group of three. Can you tell me what are the Dobereiner's triads? Lithium, sodium, potassium is one triad, and later calcium, strontium, barium is another triad, and you have chlorine, bromine and iodine as the third triad. Okay, and what is the principle here? He arranged the elements in the increasing order of atomic mass such that the atomic mass of middle element is the average of first and last. This is very important point to understand. Atomic mass of middle element is the average of first and last. Okay, so this is the actual principle of Dobereiner's law of triads, right? So this was our first periodic table. And later we studied about Newland's law of octaves. Newland's law of octaves, isn't it? Say Newland's law of octaves is the periodic table which is based on the elements arranged in the increasing order of atomic masses. Elements are arranged in the increasing order of atomic masses. And here every eighth element was similar to first element. Okay, so in his arrangement you will find every eighth element similar to first element. Okay, so just like the musical notes. So this is the main point you have to remember on Newland's law of octaves. And there are many limitations, right? So you must know the limitations of Newland's law of octaves also. So what is the first limitation you will give here? His law works only till calcium, right? Say his principle, that is every eighth element has to be similar to first. No, that principle will hold good only till calcium. After calcium, his principle gets deviated in the periodic table. Clear? That is the main limitation. And another limitation is no gaps for newly discovered element. Okay, if any element has to be discovered in the future, there must be some place in the periodic table, right? So he did not leave any gaps for the newly discovered elements, right? So these are the two main limitations of Newland's law of octaves. Clear? And now coming to the third concept in the chapter, that is Mendeleev's periodic table. So here Mendeleev's periodic table is very, very important, and there is a law called Mendeleev's periodic law. I'm writing it in a short form. Mendeleev's periodic law definition is very, very important. So can you give the definition of Mendeleev's periodic law? The chemical and physical properties of elements are the periodic functions of their atomic masses. Okay, so that means the physical and chemical properties of elements are completely dependent on atomic masses. Clear? So that is the definition of Mendeleev's periodic law. And again here you must remember achievements. There are certain achievements of Mendeleev's periodic table, and there are certain limitations also. So both are important to remember. So what are the achievements of Mendeleev's periodic table? First point, I'm writing about the achievements. He arranged all the elements according to increasing order of atomic masses, okay, and conducted reactions with oxygen and hydrogen. Okay, he simply did not arrange the elements in the increasing order of atomic masses alone. He also conducted every element reacting with oxygen and hydrogen. Okay, so whatever the elements reacted in a similar way with hydrogen and oxygen, they were placed in a same groups. Okay, say based on a chemical and physical properties of elements, the elements are placed in groups and periods. Okay, fine. And second one was he left gaps. He left gaps for newly discovered elements. Okay, say for example, he called it as Eka silicon. You have something called Eka silicon and Eka aluminium. Eka aluminium. Say Eka silicon means in the sense, Eka silicon means germanium. Eka aluminium means it is gallium. Okay. So germanium and gallium were discovered during his time, but their names were not kept. This person thought that these elements had same properties, like germanium had the same properties with that of silicon. So he called germanium as Eka silicon. And later he thought that this Ga element had the same properties with that of aluminium. So he called this element as Eka aluminium. Okay, they were discovered, but names were not yet kept. Okay, he predicted that these elements can be similar with these elements, silicon and aluminium. He called these elements as Eka silicon and Eka aluminium. So this way he could predict the elements which can be discovered in future. So that is one of the major advantage or achievements of Mendeleev's periodic table. Clear? And now let us discuss about the limitations. And limitations are very important. And first limitation was no position. There was no position for hydrogen. Okay, say because hydrogen was showing similarities with first group elements as well as 17th group elements. It was showing similarities with alkali metals. Alkali metals in the sense sodium, lithium, potassium, rubidium, all these. And it was also showing similarity with halogens, means chlorine, fluorine, bromine, iodine. So he was in a dilemma where to keep this hydrogen, right? So that's why he could not give any position for hydrogen. And second most thing is no position for isotopes. No position for isotopes. Okay, so you all know isotopes in the sense the atoms which have same atomic number but different atomic masses. When he has arranged all the elements in the increasing order of atomic masses, isotopes which have different atomic masses should be arranged in various slots, right? But he did not give any position for isotope. Okay, so these were the major limitations of Mendeleev's periodic table. Okay, and now we will study the next one is modern periodic table. Modern periodic table. So here we will study about modern periodic law. Modern periodic law. This is very, very important. Okay, so what is the definition of modern periodic law? Chemical and physical properties of elements are the periodic functions of their atomic number. Okay, say both definitions of Mendeleev's periodic law and modern periodic law is very important. Here, the chemical and physical properties are periodic functions of their atomic masses. Here, the chemical and physical properties are periodic functions of their atomic number. Okay, so modern periodic table introduced by Moseley. He arranged all the elements in the increasing order of their atomic number. Remember this. Okay, so he arranged all elements in 18 groups and 7 periods, isn't it? So groups in the sense vertical columns, 18 are there. Periods are horizontal rows, 7 would be there. Okay, all elements were arranged in 18 groups and 7 periods. So about modern periodic table, if you want the detailed aspects, you can watch the videos on periodic classification of elements, whose playlist link is provided in the description. Clear? Fine. And you know, we will study certain periodic properties. Okay, so next is our periodic properties. So we will talk about atomic size, we will talk about valency, we will talk about metallic character, non-metallic character, electronegativity, right? So this is most important topic of this chapter. Okay, so periodic properties, the first periodic property is atomic size, right? So you must know what do you mean by atomic size here. See, atomic size is the distance between the nucleus and the valence shell is called atomic size or atomic radii. And the most important thing is what will happen for atomic size when you go from left to right. Okay, and what will happen for atomic size when you go from top to bottom. Okay, top to bottom, right? So left to right means what? Across the period. Top to bottom means what? Down the group. Okay, so across the period, when you go from left to right, our atomic size always decreases. And top to bottom, when you come, our atomic size will always increases, right? So why the size decreases when you go across the period, that is from left to right? It is because the nuclear charge will increase. Okay, so all that details I had covered in the videos of periodic classification of elements. Now I'm just revising you. Clear? And here, why the size decreases? Because nuclear charge increases. And in case of top to bottom, our atomic size increases because number of shells increases. Clear? And they would ask you, they'll give you few elements and they'll ask you which is having more atomic size, which is having less atomic size. You know, these comparative questions they will ask you. And I have also done application questions on periodic classification of elements. Its link is also provided in the description. You can watch that link also so that you will get how the questions can be asked on these topics. Clear? Fine. And the next periodic property that you have to concentrate is ionization enthalpy. Okay, or ionization energy. So what do you mean by ionization energy? It is the amount of energy required to remove the last electron. I repeat once again, amount of energy required to remove the last electron is called ionization enthalpy. Okay, so this ionization enthalpy is always inversely proportional to size. Remember, ionization enthalpy is always inversely proportional to size. So from left to right, when you go from left to right, what will happen for ionization energy? See, from left to right, our size decreased, no? So from left to right, our ionization energy increases because it is inversely proportional to size, right? From top to bottom, what would happen? top to bottom in a periodic table, top to bottom in a group, when you go, our ionization energy decreases. What is the reason? Because the size will increase. Okay, so ionization energy is always inversely proportional to size. Clear? Fine. And the next property that we are discussing is metallic property. Metallic property. Okay, so even this metallic property, you know what? It is directly proportional to size. Metallic property is, let me write it here, metallic property is directly proportional to size. Okay, so this is again very important point. Now for the metallic property, can you tell me from left to right, when you go, what will happen for the metallic property? Metallic property decreases because the size decreases. From top to bottom when you go, your metallic property increases. Okay, so, and you know, metallic property is nothing but basic nature. Metallic property and basic nature is one and the same. Okay, so basic nature and metallic property is one and the same, remember. Clear? Fine. And after that we have electronegativity. Okay, so even this electronegativity is there, no? Let me write it here. Electronegativity is inversely proportional to size. So everything you can connect it to a size and tell the answers. Okay, it's not that you have to by heart all these things. Left to right, what happens? Top to bottom, what happens? You know, don't by heart. Everything you can connect it to a size and tell. Okay, so our electronegativity, can you tell me from left to right in a periodic table, what will happen for electronegativity? Our electronegativity will increase because size will decrease. Top to bottom in a periodic table, electronegativity will decrease because size will increase. Okay, so this is about electronegativity. And now one more topic is there, non-metallic character. See, non-metallic character is just opposite to metallic character. Okay, so non-metallic character is just opposite to metallic character. So our non-metallic character increases when you go from left to right. Non-metallic character decreases when you go from top to bottom. Okay, so this is the entire things that you have studied in periodic classification of elements. This is a major concept. But the questions that they ask on periodic table can be very different. Say they may not ask you the definitions here, right? Say first and foremost, you must know Newland's law of octaves, Mendeleev's periodic table. What are the achievements and limitations? Okay, here also, what are the achievements and limitations? Next, modern periodic table basics you must know. And atomic size, what happens? Ionization means what? What will happen? Metallic character means what? What will happen from left to right and top to bottom? Similarly, non-metallic character, which is exactly opposite to metallic property. And later, electronegativity. Okay, and you have something about valency. Okay, you have something about valency. So what do you mean by valency here? See, valency is nothing but number of electrons lost or gained during chemical reaction is called valency. Okay, so this valency from left to right, I'll write it in a shortcut way. L means left, left to right. What happens for valency? Valency always increases. Okay, and top to bottom of a periodic table, valency remains same. Okay, so even this is a very important thing to remember. And you must also have an idea about the number of valence electrons present in the elements. Okay, see, always the first group elements will have the number of valence electrons is equal to 1. Second group elements will have 2 valence electrons. 13th group elements will have 3 valence electrons. 14th group elements will have 4 valence electrons. 15th group will have 5 valence electrons. 16th group will have 6 valence electron, and so on. Okay, and you must also know which element comes in which group and which period. Okay, relating to this questions I have solved in application question video. You can watch that, right? And to answer the periodic table related questions, definitely you should have a strong hold on concept. So not just the mind map, this is just a quick revision for you, but you should definitely have a clarity on entire concept. Do watch my videos on periodic classification of elements so that you will have 100% clarity on the concepts. Okay, so with this I complete the mind map on periodic classification of element, and please take a screenshot whatever I have written on a board. And let us meet up in the next session with a new chapter again. That is, I will be doing it on magnetic effect of electric current. Okay, so even that chapter is the most important one. Let us revise magnetic effect of electric current in a form of mind map. So let us meet you all in the next session, and do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you so much.